Okay, so here is Maciej Zieliński from Odra Dev, former lead ecosystem engineer from Casper Labs. Now he runs own company, software house, Odra Dev, and he made zero knowledge proof on Casper.
Yes, hello Maciej, hello everyone. Yes, we did. We executed Risc Zero, which is the framework for building zero knowledge proofs on Casper. And but this is just the first iteration. Now we are on a quest to make it much low cost, because right now it's a bit expensive. Like proving one proof costs around 2,000-3,000 Caspers, which is a bit, but we want to make it 200, even 100 if possible.
That's nice. Okay, so the zero knowledge proof is like a hot narrative right now on the crypto market. The Mina protocol has it, Alep Zero has it, so we need to have it also. So let's make the title of this video Zero Knowledge for Dummies, the new title for your book, the Zero Knowledge Proof for Dummies. So I'm dummy, I don't know anything about that. So can you tell me more about zero knowledge proof?
Yeah, sure. I just gave a speech about it, so I'm pretty prepared. So first of all, like what it is, the zero knowledge is a way to prove you that I know something or I did something, but without revealing you what. So you would believe me that I, for example, know some secret without revealing you the secret. Or there is also another way of understanding it. You could believe me that I executed some algorithm, some series of steps that I did on my side, and I give you the proof of the execution plus the solution, the output of this algorithm, and you have to prove me that that was true, that was like the right execution. So you can think about it in the model where you have a supercomputer that performs some really expensive computation, and at the end of the computation, let's say it takes 2-3 days, and at the end of it, it just generates a solution and a proof. And you on your smartphone can verify it like that. Okay. And it's very important because that changes the way we do computation on blockchain. Because right now on blockchain, if I want to publish some computations, I publish it to you, but you have to calculate by yourself again and again. So you duplicate the computation. With the zero knowledge proof, we change the narrative. I compute it, you just check it, and that's it. And this way you can achieve blockchains that have like a nodes, that like super nodes that do the heavy computation, but everyone can verify it like that.
Okay, can you show us like example? During the speech you used cards, magic tricks with the cards. Can you show the example?
Yeah, sure. But the magic tricks, it doesn't show the computation, but it rather show probabilistic nature of zero knowledge proofs. Okay, so I have a deck of cards.
Oh, illusionist. This is going to be a black magic, guys. Watch closely.
Okay, so you're my counterparty, and I would like to prove you something. So I'll pick a card. Okay, and I'm gonna tell you that this is 6 of diamond, and I'm gonna prove it to you that this is 6 of diamond. So I'll hide it so you don't. No, I'll show it to the camera. Okay, and the proof goes like this. I pick 3 cards.
Okay.
And any of this is 6 of diamonds?
No. It's only spades.
All right, so none of this. So do you believe me that the 6 of diamond is not here? It could be here, right?
Yeah, it could be here, yeah.
It could be here. We try it again.
Oh, nice. Ace and king right now, but offsuited, so I'm going to 3-bet at big blind.
But 2 tries is not enough. But imagine that I did this trick like 1,000 times. Then the chance of picking randomly 6 of my 6 is would like increase. That like 1 out of even 10,000 times, the probability of picking this card is really large. But if I show it to you that many times without 6 of diamonds, yeah, then you'll think that probably I have it here, which I do.
Yeah, you have 6 diamonds.
This shows probabilistic nature of zero knowledge, because in zero knowledge you do pointing like this, like a random drawing card, like this on the space that is really, really large. So you can imagine that you have 100 millions of cards, and by repeating this over and over again, you get the almost certainly that the card that I'm telling you that I know is mine without revealing it to you. I think I did. I think I explained it right. But
Okay, so tell us about the real use cases where we can use that in real life, or real use cases on blockchain, or crypto guys out here want to use that. Like, show me use case.
Sure. There is one use case that's really viral recently. So the new cameras from Canon and Nikon will generate you a signature for every photo you make. And then imagine that you want to show this photo on BBC. But the photo taken from the camera is not really what you want to show. It's like you need to post-process it. You need to like maybe boost colors, maybe crop it. So what do? You can do all of these changes to the photo, and if you do it in zero knowledge, then you will have a proof that you used a photo that was signed by the camera that tells you that you did it in this particular place, this particular time. So that would be like, so that would, you could verify that this photo was like this change, all the changes that was applied to the photo are applied to the photo that was actually verified by the camera. And that's like a lot of people is talking about it. So hopefully that's going to be a huge thing, and all camera producers will follow this, and then we will have like all large news will use this to publish photos, so we don't have fake news. Basically, that prevents fake news.
That's nice use case. And in crypto sphere, like, why is it sexy in crypto? Like, I'm going to what? Like, use my tokens to use that in some kind of zero knowledge DeFi?
You could, but like the good part about zero knowledge is that we could go out of DeFi with use cases. Imagine that, for example, I could blackmail you that I have a photo of you that has your face on it and face of someone else, and I could prove it to you that I have the photo because I have a neural network that identifies your face and can recognize your face, and you know this neural network. I know this neural network. You know that this is true because you run it through your old photos, and you can see that, oh, actually it detects my face. And I'm going to show you that I have a photo that this particular network shows that this is your photo with someone else. And I'm going to tell you, Maciej, I have your photo with this girl. Maybe you should like do something.
How much? Please don't do it.
But this is just like showing that we can do expensive computation inside zero knowledge that were previously not possible on blockchain. Because on blockchain, you should think about blockchain as a very slow computer. And zero knowledge is exactly for this purpose, to move a computation from the really fast machines to slow machines. And before blockchains, actually it was not useful at all, because all of our computers that we have, even smartphones, even watches, everything just gets better and better and better, and there was no use case of a slow computer. But now we have this use case of slow computer, which is the blockchain. It's like very slow, very expensive computer. So we can delegate all the computations, like expensive computations, out of blockchain, do this off-chain, as we call it, and move it to on-chain. But also, we can do it with the data availability. That also is like very related to blockchains, which means I can prove it to you that I have some large amount of data that matches some certain condition, and that could be, for example, data of your blockchain history, and I can prove it to you, and this way I don't have to show it to you, and you will believe me. So without me revealing to you, or even like without the need of moving the whole data to you, you verify it, you would trust me that I'm, as an archive node for the whole blockchain, I have all the data. And that's cool. That's really cool, because we will not need to, we will have a simple way to verify. Actually, we already do have like these systems like that already exist. We have a simple way of verifying the data history of the blockchain. So with that, we will be able to just shorten the data that is required to be verified by a single node to like a bare minimum, like even the last block. So that's really nice, because this way you will be able to run blockchain on every device, like mobile and watches.
Okay. So the main question, when it will be released? Like the whole, because you said it's a phase 1, like you're going to reduce the cost of the zero knowledge proof on Casper. So when?
That's gonna be a few months, I think, from now. The technicalities behind it is that I have two ways of doing this. One way is, maybe I'll start from something else. That during the Risc Zero process of proving a computation, there is a need to do SHA-256 hashing operation. And then when you verify, and this is the thing that we put on chain, when you verify, you also need to perform this hashing algorithm. And you need to like do it 200-300 times. And this is very computationally expensive. So what can you do is you can do two things. One is you can add a hashing algorithm to Casper, like so Casper Labs adds SHA-256 to Casper. But from what I know now, that might take like several months to achieve it. So we don't want to wait that long. So instead, what we're gonna do is we're gonna rewrite Risc Zero to use the hashing algorithm that's available on Casper, which is Blake 2B. This is its name. And with that, we need to coordinate with Risc Zero, and this is happening right now. So we are in a close contact. And I'm not sure how it's going to take, because this is like engineering, explorative engineering that we're not sure how long it's going to take. It could take a month, it could take 3 months. Yeah, because it's like going from the labs to the market, right? So it could take a couple months. Okay, guys, for more information, you have in the description the website odra.dev, so you can check more and contact with the Maciej team. And good luck. And yes, we have it. We have a zero knowledge proof also on Casper, so yeah, take it. Bang, microphone drop.